Hey, Miguel. So what are you interested in?
So I'm interested in, as a biologist, how cells communicate with each other. And so I'm very interested in cell-cell adhesion. And so cell-cell adhesion is when you have two cells attached to one another. How do they attach? Through proteins. And so there are specific proteins that act like the hands of a cell. And so they connect with each other. And so I'm interested in the mechanical aspect of that. So what does that mean? Is that if you pull on one cell, what does the other one do? Does it pull back? Do they reinforce? Do they send out more hands to stay held together? And what happens after that? So if you pull on a cell, what does the cell do in response? Instead of just pulling back, is there a what we call signaling cascade, which involves another set of proteins that will activate a certain pathway, such as replicating DNA to create new proteins or to relocate proteins to that area. And those proteins are associated with the integrity of the cell. And so more specifically looking at cadherin, alpha-catenin, beta-catenin to the actin cytoskeleton and seeing how they respond to this mechanical perturbation.
And what are you working on specifically these days?
Specifically, I'm working on shear. And so shear, if we imagine a bunch of cells flat, everybody understands fluid shear, laminar flow. So that's a liquid going over the cells. But I'm interested in what's happening in between the cells, so what we call lateral shear. So if you take two cells and you do this essentially, and in between we would have either the cell contacts, but in the case that we're studying this, we're doing a cell monolayer. So we have a monolayer of cells, essentially a sheet of cells, and we apply shear to that, and we look at what happens. And what we see is that the cells respond to it by reorienting themselves to that shear. And we're trying to understand those dynamics and the forces involved with that.
Thank you.